everyone, welcome to Chapter 13. We are going to start by talking about coordinate geometry, so we're going to be graphing equations. The first part's going to be quick and review, and then we're going to get into some circles where we'll slow stuff down just a tad bit. So, first, determining whether a point lies on a graph, whether that graph is linear or quadratic or any type of a graph. It's a substitution problem. If we have the function 4x equals 2y minus 20 or y equals absolute value of x plus 2, and we know the ordered pair, we know our x and y coordinates, we substitute. So go ahead and for these 5 problems just determine whether they are or are not on the graphs. So after substituting our x values and our y values in, we hopefully have found that the only one that's not on the graph is number 2. And that's because when we substitute our x value, our input value in, and our output value in, our two sides of our equation don't match. Moving on into the next bit of review, we talk about the coordinate plane. And when we are talking about the coordinate plane, we have our xy axes here. And the x coordinates first, the y coordinate is second. This is also known as, and you can hear I am being paged, so I have to pause. So another word to describe the x coordinate is called abscissa. The C is silent, and the y coordinate is the ordinate. These are not commonly used. You're going to be hearing x coordinate, y coordinate. That's all I'll ever use. But if that ever comes up, say in math team, something like that, it's a good thing to know. Okay, we have our 4 quadrants, and we've got our x coordinates, y coordinates, positive x's, positive y's. The origin is 0, 0. You guys know all that. I don't have to go through too much review there, but feel free to ask questions if you have any. Now, finding x and y or intercepts. Our final answers are always going to be written as ordered pairs. And if you're looking for the x-intercept, again, using what we have with our coordinate plane, if it's an x-intercept, the y-coordinate is always 0. So what we're going to do is take our function and substitute 0 in for the y-coordinate, we can solve for the x. And then vice versa. If we are crossing the y-axis, we have a y-intercept, the x value is always 0, so we would substitute 0 in for our x. When we solve for x in this case, we get an x value that is equal to negative 12. We wind up with negative 12 equals x. When we solve for y here, we get a y value that is equal to 9. But we always write our final answers as ordered pairs. So my x-intercept is going to be negative 12, 0. And my y-intercept is going to be 0, 9. So that's the majority of the review I wanted to do with understanding the aspect of the coordinate plane and intercepts and some linear stuff. What we're going to move on to next is circles. And so let's talk real quick about what is a circle. A circle is a set of all points in a plane that are given distance, that's our radius, from a given point, that's the center in that plane. And just like with lines and parabolas, we have standard forms for those equations. A line is y equals mx plus b. Parabola, we had ax squared plus bx plus c. For an equation of a circle, we're going to use the ordered pair hk to represent the center of the circle, and r is going to represent the radius of that circle. Now the formula I'm about to give you here is actually derived from the distance formula, seeing as the circle is a point, or all points that are a given distance from the center of that circle. We can use the distance formula to derive what the equation of our circle is. So without further ado, our equation of our circle is the radius squared is going to be equal to x minus our x coordinate of the center squared plus y minus the y coordinate of the center squared. And again, that's coming from the distance formula. If you remember the distance formula, the distance between 2 points is equal to the square root of the difference of your x coordinates, so x2 minus x1, quantity squared, plus the difference of your y coordinates. And if that is my distance formula, you can see how it matches up very closely with our circle formula. So, with this particular problem, if the radius is 4 and the center is 2, -3, we can plot the center at 2, -3. Radius of 4 is easy if all I'm talking about is 4 units to the right or left. We have a point here and a point here. Not there. Here. Up or down, we can go here and here. But how do we identify the specific points that are all along the curve here? All of these points are represented as well, and it's not as easy to sketch that, or it's not as easy to calculate that, okay? Or to come up with that equation. But here's what we know. We know the distance, or the radius, is 4. Okay, so I know that this is 4 because that's my radius. And that's going to be equal to the square root of, well, we have x2, we don't quite know, but we do know x1, that's the center, that's 2. So it's that squared plus, we don't know y2, but we know y1, that's -3. Since it's a -3, we can make that a plus 3 quantity squared, all inside the square root. Now if we square both sides, if I square this and I square this, we get 16 equals x minus 2 quantity squared plus y plus 3 quantity squared. That's the equation of my circle. And I can look at it and recognize that it's 2, -3 is my center, and the square root of 16 is the radius, or 4. So, going through that example, take a minute and see if you can do numbers 8 and 9. Write the equation of this circle, write the equation of this circle, and then identify the center and radius for these two. I'll press pause. Try those 4 questions. Alright, I'll give you a second here to check your answers, and I'll just keep talking. Make sure that when the center, the coordinate is a negative, that's when you're adding to your variable. And when it's a positive, that's when you're subtracting. And you have to square your radius when you come and write your equation. So you have to square 2 root 3 to get 12. And then vice versa, the other thing I meant to point out here, if your coordinate is 0, in this case your y coordinate is 0, you don't add or subtract anything. You don't need to write that, so you'll never see it written as y plus 0 squared or y minus 0 squared. You'll just see it as y squared. And then vice versa, if you just see x squared, that means you're not adding or subtracting to it at all. That means the x coordinate is 0. And make sure you simplify your radicals when you have to take the square root to get your actual radius. Okay, the 49 is not your radius, the square root of that is. And for numbers 10, 11, and 12, we are going to do a little bit of graphing and equations. So, if we are finding the equation of a circle with a center at 0, 0, and contains the ordered pair 2, 4, we don't know the radius here. The radius is going to be represented by this distance. In order to write the equation, we need the center, which we have, but we also need the radius, which we don't have. This is where the distance formula is going to play a big role. That distance formula is your radius, the distance between these 2 points. So with the distance formula, it states that the distance is equal to our square root. We're going to go ahead and do that. So my radius is going to be equal to the square root of my x coordinates, the difference of my x coordinates. So 2 minus 0 squared plus the difference of my y coordinates. Make that a little neater. We got 4 minus 0 squared, and we solve. I'll go ahead and let you finish this to see what you come up with. So in this case, what we discovered is that we get the square root of 20. Now notice I didn't simplify that because when I'm writing my equation, I'm just going to square that anyway. So I could have simplified it, but it would have been extra work. So I just left it as a square root unsimplified, and then when I squared it, it just makes it a little bit easier on me to write my final equation. Okay, go ahead and take that and try number 11, and then we'll talk real quick about number 12, which is something that we've done already. So the fact that this circle centered at 1, 3 is tangent to the x-axis, that provides us the opportunity to state that the radius is 3, because a tangent to a circle is perpendicular to a radius. So we know that this becomes 3 becomes our radius. So x minus the x-coordinate plus squared plus y minus the y-coordinate squared is equal to the radius squared. So for this last one, there's a number of ways that we can do this. First, make sure you plot all your points, and you can take a look at this. But in my opinion, the easiest way to do this is not as a quadrilateral, but as two triangles. So what I'm looking at is I know I have two ordered pairs on the x-axis. That means that x-axis is going to divide this quadrilateral that is a diagonal into two triangles, one triangle being this one on top, and the second triangle being this one on the bottom. So go ahead and take a minute, try to find the area of the quadrilateral any way you choose. So hopefully we've taken a look and we've split that up if that's the way we did this, and we found the area of the green triangle to be 56 square units, the area of the orange triangle to be 42 square units, for the area of the quadrilateral to be 98 square units. And we get 98 square units. Breaking this up, hopefully everybody is in good shape. If you have questions, don't hesitate to shoot me a message, and we will set up some time to go over everything together. Good luck on the homework aspect of this, and looking forward to section 13.2.